The Auto Flight System, AFS, calculates the position of the aircraft using several aircraft sensors. In addition, the system has several flight plans in its memory. These are predetermined by the airline. A flight plan describes a complete flight from departure to arrival. It includes vertical information and all intermediate waypoints. Knowing the position of the aircraft and the desired flight plan, chosen by the pilot, the AFS is able to compute the orders sent to the flight controls and engines so that the aircraft follows the flight plan. The AFS is divided into four main parts: flight management, flight guidance, flight augmentation, fault isolation and detection system. The first two functions are performed by the FMGCs. The last two functions are performed by the FACs. The flight management FM part has several functions linked to the flight plan, such as lateral and vertical guidance associated with performance computation. The flight guidance FG part has three functions: autopilot, flight director, and autothrust. The FMGC functions, flight management and flight guidance, are controlled from the Multipurpose Control and Display Units, MCDUs, and the Flight Control Unit, FCU. Basically, the MCDUs provide the long-term interface between the crew and the FMGCs, e.g., flight plan selection and modification, while the FCU provides the short-term interface, e.g., engagement of the autopilot, flight director, and autothrust functions. Besides the MCDUs and the FCU, the main displays presenting flight management and guidance information are the EFIS displays. The main autopilot, AP, and flight director, FD, functions are stabilization of the aircraft around its center of gravity when the autopilot flight director system holds vertical speed or flight path angle and heading or track, acquisition and holding of a flight path, guidance of the aircraft at takeoff, automatic landing and go-around. The autopilot function gives orders to control the position of the control surfaces on the three axes, pitch, roll and yaw, the nose wheel steering. The flight director function generates optimum guidance orders used in manual controls. The flight director is also used to monitor the autopilot when it is engaged. The flight director symbols are displayed on the primary flight displays, PFDs. The autothrust system ensures the following functions through the control of the thrust: speed or Mach hold, either FMGCs computed or from thrust levers position; thrust hold, either FMGS computed or from thrust lever position; thrust reduction during descent and during flare in final approach; protection against excessive angle of attack. To perform the autothrust functions, the FMGCs communicate with the Full Authority Digital Engine Control, FADEC, via the FCU and the EIUs. The flight augmentation part provides the following functions: rudder trim, yaw damper, rudder travel limitation, flight envelope protection, fault isolation and detection system. For flight envelope protection, the FAC computes the various speeds for aircraft operation, e.g. flaps limit speed, the excessive angle of attack and wind shear detection, the low energy warning, indicating to the crew that the aircraft is quickly decelerating and that thrust will have to be increased to recover a positive flight path angle through pitch control. For the FIDS, only FAC1 is connected and communicates to the CFDS for all other AFS computers. Two multipurpose control and display units, MCDUs, are located on the center pedestal. The MCDU is the primary entry display interface between the pilot and the FM part of the FMGC. MCDUs exchange information not directly, but via the FMGCs. A Flight Control Unit, FCU, is installed on the glare shield. The FCU front face includes an AFS control panel between two EFIS control panels. The AFS control panel allows and displays the autopilot and autothrust engagement, and the selection of guidance modes and flight parameters. Each pilot has an EFIS control panel to select the display on his related EFIS screen. Each pilot has an EFIS control panel to select the display on his related EFIS screens. Speed, lateral guidance and level change can be selected by the pilot after a pull action or managed by the flight management after a push action. In that case, the white dot will indicate that the reference is managed. An exception to this rule is when the vertical speed or FPA knob is pushed, a level off is immediately commanded. Four EFIS displays, i.e. two primary flight displays, PFDs, and two navigation displays, NDs, are located on the main instrument panel. Flight parameters are displayed on the PFDs, while the flight plan and navigation data are displayed on the NDs. The Flight Mode Annunciator, FMA, is the top part of the PFD. As main guidance instrument, each PFD displays the autopilot, flight director and autothrust engagement status on the FMA, the autopilot, flight director and autothrust modes on the FMA, the landing category, the flight director symbols, the various speeds and reference parameters. Two side sticks are respectively located on the Captain lateral panel and First Officer lateral panel. When the autopilot is engaged, a solenoid-operated detent locks both side sticks in the neutral position. The autopilot is disengaged and the side sticks become free when the red push button on any side stick is pressed, or when a force above a certain threshold is applied on any side stick. The engines are controlled by thrust levers, which are located on the center pedestal. Two red push buttons located on the thrust levers allow the auto-thrust function to be disengaged. Note that the thrust levers never move automatically. On the two flight control panels, located on the overhead panel, there is a push button to respectively disengage FAC 1 and 2. The AFS computers are located in the aft avionics rack. Using the MCDU, you can have access to the CFDS fault messages of the AFS. The byte of each AFS computer can be interrogated via the FAC1, and AFS test and land test can be launched from the MCDUs.